Hello, everyone. Welcome to our webinar. Today we have Ricardo Bernello and David De La Rosa on with us. We'll be going over the deviceWISE customer use case demonstration. If you have any questions, we'll be going over those at the end of the demonstration. So I'll turn the ball over to Ricardo Bernello. Ricardo, go ahead.
Hello, Kipli. Good morning. Thank you so much. It's a pleasure to be here with all of you guys. A quick introduction. My name is Ricardo Brunello. I'm Vice President for Telit. I am in charge of our industrial solutions. I'm based here in Florida, and I hope that we can have some nice time together here in this presentation. I also hope that my daughters don't enter in my room screaming like crazy as we are live. David, good to have you here also. Do you want to introduce yourself?
Hi, thank you, Ricardo. This is David De La Rosa, VP of the factory industry vertical here for us. I'm also located here in Boca Raton, and I hope today's presentation will give you some insight how many of our customers leverage deviceWISE to solve many of their use cases. Thank you.
Awesome. Great to have you here, David. So thank you so much for all of you that are joining today to see how Telit is disrupting industrial solutions using IoT really to bring digitization to a reality. So a very quick introduction in terms of who Telit is. Telit's a global company. We're traded in London Stock Exchange, and we connect basically one new machine every second. This is a really incredible number. For people that think that IoT is the future, I think this is a very clear statement that IoT is now, and that this is the technology that is really changing how things operate, mainly in industrial applications. A very quick overview. Telit is divided in three main business units. The one that we call IoT modules. Think Telit, I would say like the Intel of Internet of Things, where we produce millions, more than 30 million devices, chips that goes inside all different types of things, from industrial gateways to switches to smart meters to connected cars. Every time that you are using cellular technology, and one of the use cases that I picked here to show you is a cellular connected use case, you will need a data package, a data plan, SIM cards. And Telit's a global MVNO, so we have our SIM card plans, as well as we have the ability to control the quality, the performance, the cost of your connectivity. And we have what we call our software and platforms that is like the brain of our solutions. And this technology, we brought it from an acquisition that was done in 2013 from a spin-off of IBM Automation Group, division, a company called ILS Technology, based here in Florida, that is the headquarters for services for us. And then we bring to our product portfolio products such as SecureWISE and deviceWISE that are really bringing this reality of putting intelligence to the shop floor. Telit's a global leader in this space. I like this ABI research where they classify Telit as a leader, and I will even read here their statement saying that compared to Kepler, deviceWISE has the advantage in lower latencies. Compared to Foghorn systems, deviceWISE has more advanced IT/OT integration capabilities. Compared to homegrown data extraction and edge intelligence solutions provided by industrial automation companies, deviceWISE has more flexibility and more advanced software. Yes, deviceWISE is growing significantly in industrial solutions, and we are in all different verticals, from semiconductors to automotive, food and beverage, pharmaceutical. This example, this chart that I bring here, shows how relevant is the presence in one of the most advanced, probably the most advanced and automated vertical, that is automotive. Today, 7 out of the 10 biggest car makers in the world, they use deviceWISE as their industrial IoT platform. 10 out of the 20 tier 1 companies in automotive, they use our technology. So, and the reason for this is that because we are really bring more and more productivity to these customers, is we are helping them on making things better. One of our vice presidents here has a very interesting statement. Normally he says, IoT exists for 3 things and 3 things only. For you to make money by having disruptive types of services and offerings and products to the market. So our technology can help OEMs, machine builders, to have a better product that will bring new functionalities to their customers. We can help manufacturing companies in terms of making their things better, cheaper, faster, with better control by having the connectivity to their machines. And we can let our customers to basically stay out of jail, to stay compliant in terms of the regulations of the sectors that they are. This slide here shows the big picture of our industrial IoT suite, and that we will give you more examples how a couple of companies are really bringing significant benefits on deploying this technology. Every time that I think in terms of industrial use cases, I like to divide this in 2 main groups. I like talking about connected factories, how you are using IoT on the shop floor, how you are using IoT on how you are building things, and connected products or connected machines, how you are remotely connecting your devices that might be in your customers' facilities, devices that can be geographically spread all around the world. So basically, what is deviceWISE? deviceWISE is a software. This software can be installed based on anything. It can be installed on a Windows computer, on a Linux computer, in your data center, in small gateways, cellular or non-cellular. When you install deviceWISE on your shop floor, in your factory, for you to collect data from your machines is as simple as defining what is the IP address of this device, and you have all the tag trees, all the data available in the controllers, ready on deviceWISE for you to read them and write them. All the communication that we have with deviceWISE is bidirectional. So I can collect the data in real time from torque tools, from robots, from RFID sensors, from PLCs, DCS, and so on and so forth, transform this data and push this data in different types of systems, databases, as well as I can read data from databases or systems. Let's say that you are running an MES solution that is telling what is your next part number to be produced. deviceWISE can monitor this information from the system, understands what is the next part number to be produced, push the recipe from a database, reconfigure the recipes in your controllers. When you have your machines in line with your systems, we can start the line. Not only this, we can monitor in real time your devices and push this data into screens, dashboards, and HMIs, showing your productivity and your KPIs in real time. Also, with deviceWISE, as I will show you, has a data visualization tools that you can push see these things, but not only see, you can create HMIs in front of machines to augment your data availability, to provide feedback to operators, and also to add buttons or text boxes to your operators so he can tell exactly what is happening there. So not only you know what is the performance of your machine because you're reading the data from the controller, as well as you can have inputs from the operator commanding your line or augmenting the data that you have here. Many companies are using cloud solutions such as Microsoft Azure, Google Cloud Platform, Amazon AWS to do enterprise applications. deviceWISE has the connectivity to these clouds in bidirectional way. So with deviceWISE, you can push the data from every single machine that you have on your shop floor into these applications without writing one single line of code. In a couple of minutes, you can set up your system and have all your data flying to the cloud. And from the cloud, depending on the algorithm that you're running here, changing, for example, the configuration of your line, the performance of your machines. So that was how I explained the connected factories use cases, but you also might have connected machines. Let's think that you are an OEM, that you are producing machines for certain process. You could be producing presses, or you could be producing, let's say, car wash machines. If you are producing a car wash, probably you're selling your machines, or you are selling services using your machines to different customers, maybe gas stations, and these gas stations might be distributed all around the world. They could be, you could have 1,000 gas stations out there. You can install deviceWISE in gateways. Probably having a cellular gateway here would make a lot of sense. And deviceWISE can collect this data from the machines that you have completely remote. And using the Telit cloud, the Telit IoT portal, you can have remote access back to these devices. You can open a tunnel and change the logic on your controller, or you can let your gateway changing the configuration here. And if, for example, if I need to run a campaign and change something on the logic only for my equipments that are in Florida or in New York State, I can run a campaign here and do all my device management and my connectivity management basically using the Telit portal. I also can push all this data straight to the public clouds so you can run your applications here. Or you can have deviceWISE providing you data visualization for you and for your customers, as well as you can have your remote devices connected to your enterprise systems. So for example, your remote devices can open tickets directly in your SAP PM, or can open orders directly in your ERP system for certain process. So this is how we create the full configuration for all the different types of IoT systems. With this, we really can help companies to transform the way that they produce in the reality of Industry 4.0, where all the devices become interconnectable. The machines are not only machines any longer, they are data points, and you have a completely flexible architecture here. For you to collect data from the machines to systems and systems from machines is as easy as installing one system, and then you have this completely transparent layer between any asset to any industrial system. Not only we have the ability to push the data from controllers, from machines, and from sensors to your systems, as we have a bidirectional way and we can intercommunicate different systems in your IT infrastructure. So we have customers that they use deviceWISE not only to extract the data that is running on the shop floor, but also as an integration tool in between systems, making their MES to better talk to their ERP system based on a certain logic, or integrate their ERP system into Google Cloud or Microsoft Azure or AWS. deviceWISE, as I said, is a software. This software is divided in three main pillars. And David, as soon as I stop talking here, I tend to talk a little bit too much. Sorry, David. He will show the software running here, but the software is divided in three main pillars. deviceWISE comes with the device access layer. So this means hundreds of drivers for you just to say what is the data that you want to collect. So we have a policy, let's say that we don't let any machine behind. So with this library, we can rapidly bring the data from all the devices that you already have connected at your network. And we also have the ability of adding external instrumentation, reading IOs, electrical signals, digital and analog, pushing data even from things that are old or that were not planned to be connected through network connectivity. The way that you create all your logic is also with no code. deviceWISE is a no code platform. So you can drag and drop blocks of logic. You just create your flow of logic, and now you can do this complete integration between all your things, all your systems. And we have our enterprise access layer where deviceWISE can intercommunicate to all the different ERP, MES, systems and cloud solutions that customers have. So basically, deviceWISE is not one product. deviceWISE is a platform. By being a platform, you can create endless types of solutions. So what is the value for you to have your things connected to your IT systems? What is the value for you to collect data from your machines? You can create multiple applications that will make your line more productive or make your product more appealing to your market. You can have this complete integration and automation out of your machines. So we can make a Siemens PLC to talk to a Fanuc controller, to talk to a Mitsubishi CNC, and so on and so forth. So with this, we can integrate different brands and different protocols in a completely transparent way. I have a customer that the biggest challenge that they brought us was in a certain line that was cutting metal and doing parts for implants like hips or knees replacements. The challenge was they had a CNC there. If I remember this correctly, it was a Siemens CNC. The challenge was this line was completely manual. Every time that a part was cut, they collected this part, they put in a prober tool in a measurement system, a quality control system. They collect what is the results of this cut, and they go there, do the calculation, and write back the offset on the CNC, recalibrating it. With deviceWISE, we could integrate this, making the CNC to natively talk to the robot. Every time that the cut was ready, deviceWISE was telling the robot, go there, pick up the part, push the part into my quality control system. Measure the part, take the results of the measurement, calculate what is the offset to the CNC, and write back the offset here on the CNC. So with this, we did this complete integration and automation using deviceWISE to have this more productive line. In the same customer, I asked it, how are you doing preventive and predictive maintenance? Do you use any type of software? And the person told me, yes, we have SAP PM. And how do you feed SAP PM? He said, we have a person that walks across the lines with a notebook and takes notes when it's the time for you to recalibrate a certain machine and go there and open manually one ticket in SAP PM. When you have an industrial IoT platform bringing data out of your machines, you can do the data logistics. You can automate this process. And then the way that we implemented that was deviceWISE was reading, for example, number of cycles, power consumption, precision on the cut, and opening automatically based on just a very simple configuration, something that can be done in maybe a couple of hours, opening directly the tickets into the enterprise system, into SAP PM, in this specific example. And the same example, I already said how the quality control system was connected in real time, measuring all the parts. But also, as we have the connectivity of these parts, I know if the machine is running or not. I know how many good parts and how many bad parts this machine produces. I can create quick KPIs, such as OE, to measure the efficiency of my line. And I can have all my machines connected to my IT, so I have a complete visualization and control on all my industrial assets that might be producing millions of dollars every single day. And connecting to artificial intelligence platforms and running algorithms was, it's as easy as it can be. All your data is connected. So IoT is a journey, and definitely by having a powerful IIoT platform such as deviceWISE, we significantly help our customers on walking through this journey. Let's go to the use cases. That is the main objective of this webinar here. What is an IoT factory and a non-IoT factory? The way that I see an IoT factory is identical as a non-IoT factory, but we have the ability of bringing the data of all the different types of components that you have on your OT space, interconnecting them with your IT space. And this is what we did for this specific customer. The customer had the challenge of having the visibility of the process. Some of the data was coming natively from the drivers of the machines that we could get. Some of the data of the machines that were used were very old legacy machines, and we used just a hardware adapter reading data from electrical and digital signals. deviceWISE was doing all the calculation, pushing the OE data into HMIs and dashboards that could be seen by the customers, pushing the data in terms of dashboards in end-on displays, bringing real-time information for rapid response on the line, improving the timing it takes for jobs to be done in the line, and having all the data accumulation, concentration, and treatment in the company IT systems. Here, I can even show you very quickly how easy it is for you to create an application and for you to do the data visualization when you have deviceWISE. So basically, we can use deviceWISE to do all the calculation of all the KPIs. And we can use our dashboard viewer and our HMI creator for you to create these applications. As simple as you create a PowerPoint. You just select what are the widgets that you want to use. You just drag and drop these widgets, and now you can create them as simple as you can see here. Pretty cool, right? Oops. Sorry for that. So here, just one example of how you can use your HMIs running on simple tablets in the line. So you can not only let the operators, let the people to see the results, but also letting them to interface with the system, adding inputs. So now every time that I have a downtime, every time that I have a machine that is not running, I can read the reason why this machine is not running, but I also can let people that are in the line to aggregate data to my system so I can classify downtime reasons, as well as I can do immediate actions such as calling maintenance if I have a problem here, so I can reduce my downtime. And in this specific example that I will bring here, this is a real use case that we deployed. This is the largest electronic producer in the world. This company is producing cartridges for ink printers and is the biggest brand of ink printers in the world. They produce several thousands of cartridges per hour. The biggest challenge that we had in this project here was the speed of the transactions, was a high frequency line that was producing so fast, moving so fast, that collecting this data on the frequency that this data was being created and erased was a big challenge. This company tried to hire 3 other suppliers, and none of them could handle the data collection. As deviceWISE is a real-time data collection engine, we can collect this data in real time. We used only deviceWISE technology here to collect this data and to transform this data in real information. We created here the digital twins, and in basically 3 weeks, only 3 weeks, we were collecting the real data from all the different machines in this very complex line. We created the digital twin so managers can see the results of the production of the shift in real time in this nice control room or in their mobile phones or tablets all around the line. The results were great because now people see how the line is running. Every time that we have a problem, deviceWISE identifies the problem, create an alert, and push for rapid reactions out of people. deviceWISE can be implemented by system integrators or even by the people that are working in the line as this becomes a no code. And every time that you have a change in your process, you can just drag and drop one more block of logic, as we will show, and improve your process and the way that you are visualizing the things and controlling your machines. Now, let me go to a different type of use case. Let me go to a connected machine. I talked about the connected factories, how you can improve the data available and the integration on the shop floor. But what if I am an OEM? What if I produce things and I want to improve the servitization of these things? I want to sell services, spare parts, and make my customer happier with my product. Yes, I can use IoT for this. And in this example that I bring here, it's a real example of one of the biggest, if not the biggest, laser cutting machines in the world. They use deviceWISE, and deviceWISE goes installed in every single machine that they sell to the market. deviceWISE can read the data in real time from all the different machines, their machines, and eventually some of their competitor machines, transform the data coming from the controllers of these machines into information for you to have a more intelligence application, pushing the data into the SAP ERP systems or databases from their customers. So now their machines can natively talk to the customers' systems that they use to control. But not only that, the biggest challenge of this customer was not only making a more intelligent machine, but also selling additional services to their customers. The way that we engaged with this customer was we put the Telit IoT portal to remotely control all the hundreds. Today, this customer has almost 1,000 machines connected. We have the ability of opening remote tunnels. So the engineers of this company that could be in the United States, in Japan, or whatever, could remotely access these machines on a very secure way and change and control and do maintenance on these machines without the need of jumping into an airplane. Not only this, the machines itself were telling the company when is the next time for a maintenance and calibration, when is the next time for changing one specific part, or what is the productivity, so the owner of the factory could be anywhere, seeing if their machines are running properly and at what pace, and taking actions completely remote. So this is the power of IoT. IoT can be completely integrated on a fully contained application inside the four walls, or it can even be used for you to collect data from machines that are spread all around the world with all your ability of doing the device management, connectivity management, and remote remediation. Another very quick example, in this case here, in the oil and gas, where we are collecting data on the very same way from different machines. These machines are inside trucks. These trucks, they have industrial equipment. deviceWISE can read the data from the industrial equipment, but not only from the industrial equipment, but also from the engine of the truck using J1939 protocol, collecting the data, pushing this data straight to the application. This is a specific customer is using Azure for the application, but doing all the device management, the connectivity management, and the edge logic running by deviceWISE. So, David, if you're still there, I would like to pass the ball to you so you could show the product running, and then we can go for questions and answers. David, I think you are on mute.
Not anymore. 1 second. First of all, just to make sure, Ricardo and Kipli, do you see my screen?
We do.
And obviously you can hear me. That's good.
Correct.
Well, thanks, Ricardo, for the quick intro. And then I'm gonna go over. I know we don't have a lot of time, but what I'm about to show you will give you a good flavor of what you could do with deviceWISE. You could certainly feed quality systems with data. You could compute, OEE, which is the bread and butter of factories. We want to make sure the equipment is used and scheduled properly. Another aspect is preventive maintenance to keep the equipment going. As Ricardo mentioned, some factories to this date, they do maintenance on fixed schedules, which result in equipment kind of not being available instead of when they absolutely need to do it. So the preventive maintenance is one key kind of use case that you could realize with deviceWISE very easily. And with the advent of cloud-based systems like the Azures, the MindSpheres, the GCP, and the IBM Watson, you could also purchase analytics as a service. You know, you hear the terms machine learning and so on, but the reality, the business outcome is tell me when I need to do this change ahead of time. Give me enough time because I cannot afford downtime. And there is another aspect that you could realize very easily with deviceWISE is interactions with MESs. You know, there's many MESs in the market. Some are based on Microsoft systems. Some are SAP, like SAP ME, for example, and many other ones. So with deviceWISE, we become the easy conduit to data in and out of the shop floor for the MES. So many use cases. So just rehashing quickly what Ricardo went over, deviceWISE is a software agent. It runs on many kinds of operating systems, hardware combinations. Windows Server is perhaps the most common for us, so it runs there. We have the 32-bit version of deviceWISE for legacy systems, 64-bit version. For Linux, you could run Linux 64-bit like CentOS and Ubuntu and the like, 64-bit and 32. We also provided in a Docker container, so you could kind of use more of a Docker managed kind of an environment. Not that you would run a Raspberry Pi in production, but it runs on Raspberry Pis. And some of our customers run it on big IBM mainframes. They call it P-series, the big Unix machines. So it doesn't matter. We run in all of those. The software you're seeing right now is called the workbench. And it's a view into the deviceWISE agents running. So this happens to be my laptop from which I will be presenting today. This is a deviceWISE instance somewhere on our network. It happens to be running on a, you guessed it, Raspberry Pi. This is inside a Mitsubishi PLC Q-series. This is a very small Siemens gateway. It's like an industrial Raspberry Pi. This is a Cisco switch. So if you have an industrial switch or gateway, like from Cisco, you could run inside there. So it runs on many kinds of systems. So as Ricardo indicated, deviceWISE, think of deviceWISE an OT IT bridge, fully bidirectional. So we call this, of course, the OT is generally the device layer. And then so this is how you work in deviceWISE for the device layer. This is the IT layer. And this is where you do the logic. If you recall the 3/3 that Ricardo mentioned, this is the lowest third, here's devices. And this is similar in concept as to OPC providers like Kepler or Matricon. So we have this layer, and then we also have the logic and the also called business logic or edge logic and the IT connectors. So we're gonna kind of briefly show you how we do the OT connectivity. Basically, deviceWISE is modular. You could install what we call plugins. So we have all kinds of drivers. We got in excess of 100 drivers for various kinds of devices. We call them on shop floors. This is torque tools, unknown displays, more torque tools. BACnet is a facilities automation network protocol. Backoff is a soft PLC, more torque tools. FANUC CNCs, more torque tools, robots, and the legacy GE CNC line, more torque tools, empty connect, which is a kind of a standard machining. All the Mitsubishi PLCs we support, Modbus, of course, OPC UA client. If you have a system that has a UA server built in, all the Omron line, this is all supported, all the Rockwell line, all the Siemens line. SNMP is an interesting one because you could instrument even your laser printers and office equipment, even network switches that have SMP clients, more torque tools, and RFID, and so on. So very, very comprehensive library of device connectors. So I'm going to show you a couple of examples how we do this. So let's just define a control logics PLC. So you provide a name, and then what you do is you pick the type from the list. and then you put this IP address and pick the slot number. So this is the very basic configuration. Validate does a quick check that it is an Ethernet IP connection. So you save this, and then you press start. And then what's going to happen here is that we're going to go inside the PLC. Sorry, let me see. Go inside the PLC state and do a full introspections into the tags. So this is all the tags that are inside the Rockwell PLC. So you don't have to import anything, just we go and enumerate it. We support program tags, controller tags, everything that those Rockwell controllers support. We can get at just about. And just for good measure, I'm gonna do a CNC here, which is a little different than a PLC. And then what you do is just pick the type and put its IP address. And again, you could do a quick check that, yes, I can talk to it. You save this definition, and then you start. And then we sort here by state, go to the top. And now you have the full FANUC CNC address space available to you. So you have access to servo information, access, and of course, the PLC part. It's called the PMC of the CNC. So this is how easy we talk to devices, and generally we do this to all devices that we can, that the hardware allows. And this is the beginning of any industrial IoT application, whether it's OEE, MES, quality, preventive maintenance. So this is the beginning of it all. The next part, and then we have numerous drivers, and they are all available to run on Windows, on Linux, with the exception of OPC-DA. But generally, our drivers are native done, bare to the metal, so they run in many of the operating systems that we support. So the enterprise connectors, which is the IT side of the OT-IT model, is basically what can we exchange information with, and basically we support basically everything that is IT commercial out there. Databases is very common, of course, and then we support the IBM line, SQL Server, MySQL, HANA, Mongo, Postgres, Oracle. They're all supported right out of the box. And again, all you have to provide in the case of a database is the name, the database name, where is it, and credentials, of course, and the type. And then once you are connected, you could, for speed, you could have a connection pool size, logical unit of works kind of information that you could set up here for, logical unit of work. All our IT connectors support a feature called store and forward, which simply means if the IT endpoint is unavailable for whatever reason, all transactions are kept. And when the IT resource is back online, then the data is sent. So basically, there is no data loss. Of course, there's limits on storage and so on, but the idea is no data loss. So we support RESTful or HTTP kind of communications. There are many business systems that are front-ended with a web server, for example. So you could send a JSON or XML payload bidirectionally to these endpoints. JMS is Java messaging system. You have SAP NetWeaver app server or IBM WebSphere or WebLogic. They implement JMS. MSMQ is a Windows Server middleware, and many MESs for small mid-range businesses are built on top of Windows Server and MSMQ. And with this, you could exchange transactions bidirectionally with the endpoint. So basically, you pick a service bus and you put a queue, and you could put data on a queue, and you could also wake up when data is sent to you. SAP, so we can communicate directly with SAP ECC. All you have to provide, again, is simple. What is the name of the client, the system, and credentials, and the addressing. Where is it? And then when you use SAP Transport, we call it, you have access to any BAPI that this user has access to. Preventive maintenance is built in the form of a BAPI, so you could send parameters, get results, and so on. That's on the SAP side. And then, of course, SAP IBM Watson, IBM MQ, and web services, which is another very common way to talk to IT systems. So I call this IT terrestrial, on the ground, on premise. And then, as you can notice here, we have connectors to cloud systems that provide a service. They're cloud-based. Of course, Microsoft Azure is very, very common. We have a couple of ingestion points. Sorry. What happened here? Uh-oh. Sorry, got a little issue here. Okay, let me see. Sorry, I don't know what happened here. Yeah, I don't know what happened. It appeared on me on the workbench. So Azure has a couple of ingestion points. We could deliver payloads to the IoT hub, they call it, or the event hub, and we also receive information from Azure into us unsolicited. AWS IoT Core when it's on the cloud, and it's also called green grass when it's on premise. And Azure has something similar, Core IoT Edge. We also support it as well. Google Cloud, as you know, Google is very heavy into the artificial intelligence, so we support BigQuery, which is used to send large amounts of data for analytics, and PubSub to do kind of like a PubSub. Many endpoints subscribe to this hub, and then they get data for various things. And of course, our friends at PTC ThinkWorks. So any IT on premise and any IT on the cloud. So now you have a numerous large amount of drivers talking to OT systems, and now you have the equivalent talking to any IT system, which is on-prem or also on the cloud as a service. So the thing that glues all this together is what we call triggers, and this is the business logic. And I'm creating a small project here, and then I will show you how we do this. And this is the no-code kind of programming, so to speak, that Ricardo was mentioning about. It's a visual, it's a flow chart. All the logic blocks here are highly encapsulated. One block talks to SAP. All you have to supply is the input parameters and maybe get the output parameters. And the way this works is the top half is called an event. And this is what triggers the logic to run. There's many kinds of events that we support. One very simple event type is a schedule event. For example, this event runs every second. That's a very, very simple, not terribly useful, but very simple. Another one is more of a scheduled, like every week of the year except the holidays. Say in the summer, a week of holiday, and then at the end of the year, another week. So you deselect what you don't want it to run. So fundamentally, this trigger will run and do something every maybe end of the week. You could have another trigger that runs at the beginning of the week because you're keeping track of weekly production. Maybe the beginning of the week you clear a lot of counters and settings, and at the end of the week you totalize and send them to some IT system. So this is what we call a trigger based on a schedule. There's other kinds of triggers based on maybe on a device data. So for example, if we want this trigger to run because this bit changes on the Rockwell PLC that we defined earlier, if it changes or if it's equal to 1, then the logic down here will run. So this is also very common, in OT, because PLCs set a flag, we look at the flag, and then we do, and then you pick the rate. How do you want this to be read? That's one kind of trigger. More sophisticated trigger is, for example, a PLC logic event, and this is when the devices, like a PLC, sends you the data without you requesting. So we support all the ones that the hardware supports it. Siemens has multiple kinds. Rockwell has message instructions. Mitsubishi has different ones, and so on. The beauty here is that your data is comes with full data integrity. There is no polling. There is no timing issues. Your data comes when it comes, and the PLC knows when you receive it. So this is a very powerful way to deliver data to PLCs, to deviceWISE. Just for the sake of argument, let's do something every second, and we're just going to create this trigger, simple PM application. Now, what we're going to show you below here is how we do the logic, right? So one very simple trigger to illustrate what we can do. Networking, there is an email function. You drop it here, connect the dots, and there is a simple, every second is going to deliver an email to somebody. So of course you have to put the server credentials and what kind of security and authentication, who from, who to, attachment, and so on. So this is a very simple, preventive maintenance application. Of course, not every second, but maybe because some sensor tells you that there is a fault. Let's just pick maybe this bit. Yeah, bit 0 is equal to a 1. Then it means there is a fault, and then it sends an email to the maintenance manager at the plant, and boom, away you go. A more realistic way to do this on a large corporation is we will create an SAP PM ticket. And this is done through what we call our enterprise action. So you drop it here. Of course, you have to develop that transaction. Just select it. And then when this runs, or in addition, it could open a SAP PM ticket, or it could be a Jira ticket, or it could be an SAP Maximo ticket. So this is how simple it is to develop, business application. Now that's just PM. If there is a quality system you need to be fed, of course, the transaction then is going to go to like a historian or relational database. But the paradigm is the same. You pick the event, whether it's old or the data is being streamed into us, and then you deliver the data to the end system, which is a historian or a database. If it's for OEE, then you could do some mathematics here. We have you could do if then else, you could do expressions, you could do computation, and then you could have a running OEE, and then you could visualize it. So that would give you kind of the OEE kind of use case. But again, it's the same tooling, it's the same triggers. If you notice, there's nothing here specific SAP or Maximo. Everything gets abstracted, which makes the tool very attractive. You learn one thing and you actually hit many systems at once. There are some specific logic here for Azure, for example. So if you want to deliver data to Azure, you could do this. You could drop it here and pump the data to Azure. Or if you are waiting for Azure to send you a signal, then you wait on an Azure event. They send you what they call telemetry, right? So when Azure pumps the messaging to you, your business logic will run, and you take some remediation on deviceWISE, maybe setting a stack light or turning off something on some device. So that's kind of briefly what deviceWISE does. I mean, I know we don't have a lot of time. I could also tell you that we have a very robust role-based security system where you could define roles and allow some users to have access down to a tag if needed. So very, very granular, lots of control. And if your enterprise uses like LDAP or Active Directory or ADFS, then you could turn it on. And now the whole role-based security of deviceWISE is managed by the IT infrastructure. So like a maintenance person cannot write to some tags, maybe only to an e-stop or a diagnostic tag, and that's all they will see. An IT person may not be allowed at all to touch a PLC, and vice versa. An OT person may not be allowed to touch a transaction to a BAPI in SAP, and so on. So in a nutshell, that's kind of what we do. Very briefly, you could do just about all the use cases we mentioned before. You could do MES, of course, using relational databases or queuing systems, or you could do the cloud as a service with GCP, Azure, and the like. You could do preventive maintenance and predictive maintenance with the same cloud tools. You could do OEE and display OEE on handhelds, iPads, phones, and giant displays, and even random words. And of course, you could feed a quality system. So at this point, I guess I'll turn it over back to Kipli or Ricardo for a Q&A session.
Perfect. Thank you so much, David. And Ricardo, thank you for your presentations. So we have quite a few questions in the chat here, so I'll just start out by reading them one by one, and David and Ricardo, you can answer them. If anybody else has any additional questions they'd like to ask, please feel free to put them in the chat. So the first question we have here is, how do I interface your chips in a PC-based edge system?
Ricardo, that's more for you.
Well, on the question, I understand that you're asking in terms of how Telit chips can interface with the Telit technology. We announced recently a brand new technology called Module. Basically, this is an agent that provides you all device management functionalities straight from the module. We didn't have time in this presentation here to go through the details in terms of our device management cloud solution, our what we call the IoT portal. But basically, we can interface with these remote devices that are connected through cellular network into a device management system like that. So, it will be a pleasure to go through more details later. If you want, please drop us one email, and we can have a specific demonstration of this part of the technology.
Perfect. Thank you, Ricardo. And the next question we have is, can the deviceWISE device, PLCs, drivers pass streaming data directly as Kafka, Producer, or NiFi?
Currently, we don't have a Kafka connector. It is on our roadmap. And when it is available, you will be able to basically either sample data from those devices or receive a stream originated from those devices into Kafka, just like it would be if you were to stream to the existing ones today, like GCP, Azure, and Watson, and the like. It is a roadmap item for us.
Yeah, but as well as you have in Kafka many IT connectors, deviceWISE can also play these IT connectors. So in case that you want to have deviceWISE talking straight to systems, as we talked here in terms of having deviceWISE collecting the data from the controllers and streaming this to specific systems, deviceWISE has these capabilities on the IT connectors. So.
Perfect. And then the next question we have here is, can your native drivers pass data directly, not via OPC, to any SCADA system or HMI? If so, which SCADA or HMI?
That's a good question, but it's a pretty generic question. There are many ways to deliver data to HMI systems. Of course, OPC is a very common method. Some HMI systems present a Modbus server interface, so we become a client and we put data there. So there's a variety of ways to do it, but it depends on the HMI in question. With our display builder, you basically have the HMI right in the product, so that would be another option. But if there is an existing HMI, it depends on the HMI and the mechanisms to deliver, data to it.
Yeah, but basically SCADAs and HMIs, they are systems that by nature, they are built to be open for data ingestion. And we can do this ingestion. Maybe what we can do is we can consume the data natively using our native drivers for you to have zero latency. So when you are collecting data from Siemens using an S7 protocol, for example, translating this data into an OPC and publishing this data to your SCADA through OPC, or if you have, for example, RESTful interface or any sort of database interface with your SCADA, we can also push this data into SCADA. So we have, go ahead.
Yeah, there's another, I forgot this point. We have an extension, a plugin, kind of like a driver. We become an OPC UA server. So all tags from using the native connectors and then available. So if the HMI has a UA client, which likely does, then you could just point to us and get the data. The question is the data integrity and the streaming, right? If you have a sample system, you will miss samples if you have this methodology. Best is gets ingested natively into the end system. That way you'll have all samples. But if it's for visual counters and things of the like, yeah, you could miss a few and it's not an issue. But so that's another option. We become a UA server, and actually we become an OPC DA server, and then all of our device connectors and their tags now are available in the address space of DA and UA.
Yeah, but generally this tends to be a very simple ingestion. Please feel free to contact us, and we will be very happy to support you in this project.
Alrighty, and the next question we have here is, without Telit Cloud, how can I log on to the local system from remote location on VPN?
Just a VPN client. Yep, that's the only way. If your system is remote somewhere and you don't use our cloud platform, then you're left with VPN type technology to access it.
Yeah, and deviceWISE runs in any type of computer. It could be Windows, it could be Linux. So if you already have remote access to your node, to your machine through VPN, there is nothing wrong about you having deviceWISE running on the edge, doing all the edge logic there, and the distribution and the logistics between machines and systems locally, and then you can have just the VPN accessing this node as you would do it with any other type of PC application.
Very good. And the next question we have here, for legacy machines, the I/O module used to interface this Telit is Telit's product? If so, what is it called and what protocol does it talk to device-wise?
Yes, we have one product that is called Smart I/O. Basically, the Smart I/O is an I/O converter. We can read the electrical signals, the digital and the analog I/Os that you can wire up on the I/Os of the machines, or even add external sensors to this machine for an instrumentation. We have the driver for this specific I/O, and then we can consume the data coming straight from this hardware interface. There are many ways that you can consume data from external sources, but certainly this should be the easiest one, and the name of the product is Smart I/O.
All right, and this next question is in relation to the display builder. Can I have the widgets and screen development as in-premises installation?
Yes, our the dashboard builder, all the HMIs that you saw there, it can run completely on premises, so you don't need to have connectivity to the internet at all. This data doesn't need to be published in the internet. This can be completely on premises. In that specific example that I gave in my presentation with the control room, all those displays, they were running in browsers, but only locally, so completely on premises.
Very good. And then in relation to the electronic use case for the manufacturer, someone asked a question, electronic producer fast data is not clear. How were you achieving it?
David, do you want to comment on that? How we can collect the data in real time, no latency, so we make sure that we don't lose the data on controllers that are changing the text very rapidly?
Yeah, so we use this methodology we call events. So the devices are the ones that are sending you the information. So we're no longer polling, because if it's a very fast process, you will invariably miss data no matter how fast you poll, because you have network latencies, you have all the things on the network and so on. So what we did, we asked him to switch the logic around, is when parts went by to fire what they call a message instruction. They were using a lot of Rockwell equipment. So we were basically getting events as they were happening in the machine. So we catch them, they get buffer, everything gets displayed. That's why we were able to do it. If you use a polling methodology, you will likely run out of use very quickly, because there's just the physics and the latency. It cannot be done. or it cannot be done easily, but I believe it just cannot be done. If you don't do an event, then you will miss. And that's how that was a very successful project.
And we have a very interesting also paper that we can share the link with you if you send us one email, that we compare the performance of deviceWISE with the performance of open solutions. So basically like OPC. And deviceWISE being a real-time system, our latency is very close to zero. What can make sure that you have the data reliability on all your data collections. Not only this, when you need to insert data in a controller for a machine to start a certain process, every millisecond that you take in terms of latency represents downtime in your line. So sometimes what really happens is we can increase the productivity of the lines by providing data faster out of that line, or in the example that I give, we can provide more reliable data, making sure that you're not losing data just because your pooling is not fast enough for you to collect that data. So real-time data collection and data delivery is something extremely critical, mainly in discrete manufacturing, when you have high frequencies machines that are changing the tags on a very fast way.
Very good. And the next question we have here is, can deviceWISE act as an OPC UA server for all the data it collects from various PLCs?
Yeah.
Perfect. And then we have another question here. How do we have redundancy at the edge where deviceWISE is running? And how does this RS-485, RS-422 do a changeover without a bump over?
Can you say that again, please?
Sure. So the question was, how do we have redundancy at the edge where deviceWISE is running? And how does this RS-485, RS-422 do a changeover without a bump over?
Oh, I see. So one easy way to achieve that kind of high availability is having a couple of deviceWISEs on the same bus. The 422, 485 is a multi-drop, kind of like a serial interface. So you could have multiple nodes in it. So that could be one way done with hardware and using, another device-wise node. And then if one node fails, then the other one can keep on reading, and they both could keep reading. It's just the throughput on the wire is kind of the key. This is at the hardware layer. There's high availability done at the upper layers where you could use clustering, or our big customers use load balancers like F5 balancers, and they have multiple device-wise nodes behind it, and they fan out the work. But that's more a high availability at the enterprise level, not at the hardware level. So there's various ways to tackle this problem.
Okay, and then the next question we have here is, all new devices are capable of new IoT protocols like MQTT capabilities. Where are you positioning deviceWISE in those cases?
MQTT, it's a very robust protocol on top of TCP/IP. There's still issues with payload definition. Unlike the Rockwells and the Siemens and the UA that have very strong data models, MQTT is above the transport layer, but not very much. We do support it extensively. A lot of our customers use MQTT kind of like a middleware to connect things, but for us, it's just another mechanism. It's a little higher than TCP. So to us, it's just another transport, and it is supported. We have it, and you can use it. There's not a lot of PLCs and devices and sensors that have MQTT right on it, but in time that could change. For very small sensors, for environmentals and things, I think is more appropriate, and I think there are many like that. So all you have to have is a broker, and then device-wise then subscribes to it and gets sensor data that way. But we fully support it. We don't see it as competition.
Okay, and then we have just a few more questions here. The next question is, edge gateways that have deviceWISE, how is device management being performed?
So if the edge devices are like a cellular small Linux gateways, like a Multitech, Cradlepoint, Siemens, you typically do device management using our portal. Our portal or our cloud service sweet spot is the device management. So when you have 10,000 of those in the field, you want to know that your logic, like the triggers and the flowcharts that you saw, are all up to date. The firmware is up to date, so you could do firmware updates. But all that goes through our portal, our cloud service. And if they have cellular connectivity, then we have a feature in our portal called CM, or connectivity management, and that's how you manage the data plans, the data rates, enable SIM cards, disable SIM cards, because we have interfaces with the cellular providers system, like Jasper AT&T, for example. We interface directly, and then you could see all your SIM cards. So the net is you use our portal, our cloud platform, to do the DM, device management, and connectivity management. Otherwise, it will be very difficult to do.
Thank you, David. The next question we have here is, if there is a text or CSV file which is continuously being updated by some legacy SCADA, how can deviceWISE keep getting the latest insertion in that file on deviceWISE unsolicited? Can you show that logic or function?
Actually, there is a way to do it today. We have, if you go into the staging group, you're going to see a local DB import. Then what that will let you do is import this CSV into what we call the local database. So it's a two-step process. The first, you need to bring in the CSV into the local database, so it has a relational flavor to it. That's one part. The root event here is a file system event. So you pick a directory, and then when a file is put in there, the trigger will fire. If you recall, on my demonstration, the event was either a timed event or an Azure event. Well, this one will be a file system event. And when the file system event fires, you'll have information about what file, when, how big, and so on. So when you get that trigger, you will then import into the local database. And now you could do some SQL to find the last records, the newest records, for example. And then you get those records, and then you do what you need to do with it. So you would use the triggers that you saw me kind of display. It's a little bit of trigger work, and in the future, we may encapsulate something that is a little richer, that basically it does the differential and it gives you the net. Oh, only these 3 rows, so you don't have to do it in the triggers. But you could do it today, and in the future, it could be easier. So you don't have to write, complicated triggers. Not that they're complicated, but it's still writing a trigger.
Thank you, David. And then we have just 2 more questions here. How is timestamp data from files taken inside the deviceWISE?
If it's the same CSV question, there is a column on a database of type timestamp. So if you import a string, which that's what it will be on the CSV, that has a timestamp type, or designates a timestamp, then when it's imported, your table will have timestamps, like real timestamp, the 64-bit UTC type, Unix type timestamp, and then you can manipulate it any way you want, for less than, greater than, or whatever.
Very good. And then our last question here, which MQTT broker would you suggest and consider is the best? And is it essential that they have to be TR50 compliant?
Those are 2 different things. So TR50 is a protocol that happens to be implemented over MQTT. So they're not, they're separate. The one that I have used the most is Mosquito. But I don't know if it's the most robust. I am not an expert on MQTT brokers in particular, but Mosquito is a very common one. I am certain there's other ones out there. I could tell you that we have our own broker on our portal, and we have tens of thousands of devices connected talking TR50, but under the covers is MQTT. So I would say that ours is a pretty good one, but it's not something that you could deploy in your enterprise. It's something we use for IoT. for our edge connecting to our platform. So Mosquito is the one that I know that is the most common that I have played with. So I have no opinion, not because I don't want to favor a vendor, it's just I haven't played with any other one other than Mosquito.
Perfect. Well, that wraps up all the questions that we have here. David and Ricardo, thank you so much. If anybody else has any additional questions, I went ahead and put my email on a published chat, so feel free to reach out to me. And just a reminder, this has been recorded and it will be available on the Telit YouTube. Thank you so much, everybody, for joining. Have a great day.